Hey everybody, Dr. Wesselcouch here with another Math and Minecraft episode. Today, we're going to solve a combinatorics problem that arises from one of the current fads in Minecraft, Parkour. And by the end of the episode, I'm willing to bet you'll have a new favorite sequence of numbers. Alright, let's get started. Parkour is an obstacle course game in Minecraft where you want to get from one side of the lava to the next without falling in the lava. So I've made a sequence of parkour courses where each step along the way you could either go up or down to get across the lava. And in this particular one, there's two ways to do it. So first I went up, up, down, down. Now I'm going up, down, up, down. So the question we're going to try to answer today is, how many ways can you go from the bottom left square to the bottom right square, with each step being either right and up or right and down? And there's no backtracking. Before we try to solve this problem, we should count the solution when the number of paths is small. In the n equals 0 case, there's one path. In the n equals 1 case, there's also one path. We saw earlier in the n equals 2 case that there's two paths, up, up, down, down, and up, down, up, down. In the n equals 3 case, there's 5 paths, and I'll show you them now. And you could try on your own, and I encourage you to do this, that in the n equals 4 case, there's 14 paths. So the question is, how many paths are there in general? Well, let's go to the whiteboard so we can learn about the Catalan numbers. The Catalan numbers form one of the most famous sequences in combinatorics. Before I state the sequence, let me name a few objects counted by the Catalan numbers. The nth Catalan number is the number of Deke paths of length 2n. The number of different ways n plus 1 factors can be completely parenthesized. The number of non-isomorphic ordered trees with n plus 1 vertices. The number of ways to triangulate an n plus 2 gon with non-crossing line segments, and the list goes on. Recursively, the 0th Catalan number is 1, and the n plus 1st Catalan number is equal to the sum from I equals 0 to n of ci times c n minus I. The first few terms are 1, 1, 2, 5, 14. Does this look familiar? It should. It appears to be the same sequence as our parkour paths. So let's give a combinatorial proof that these two sequences are the same. To clarify, we want to show that the n plus 1 term in our parkour path sequence satisfies the same recursion as the Catalan numbers. We've already shown that they have the same initial condition. We know by induction that the ith parkour path number is equal to the ith Catalan number for I equals 0 through n. So consider a parkour path of length n plus 1. At some point, we must return to the bottom row. Suppose that the first time we return to the bottom row, we land on the I plus 1 block in that row. It's not hard to see that our path can start in ci ways and can finish in cn minus I ways, for a total of ci times cn minus I paths. Since I can be any value between 0 and n, we have that the n plus first parkour path number is equal to the sum from I equals 0 to n of ci times c n minus I. This proves that the nth parkour path number is equal to the nth Catalan number for all n. There you have it, folks. Parkour paths are counted by the Catalan numbers. Can you believe it? Let me know in the comments if the Catalan numbers are your new favorite number sequence. They're definitely one of my favorites. And share this video with your friends. It will really help me grow my channel. Smash the like button before you get out of here. All right, bye-bye.